All right, let's move to number 3. It tells you started with a saturated solution of NH3 and 100 grams of water at 10 degrees Celsius. How many grams of NH3 would bubble out of the solution if you raise the temperature to 80 degrees Celsius? All right, so let's identify NH3. So it's right here. Let's do it in pink. Okay. All right, now at 10 degrees Celsius, what is the maximum amount we can dissolve? The maximum amount is 70 grams. So let's write that down. Okay, so that's the first part. So at 10 degrees, we can dissolve 70. Now, how many grams of NH3 will bubble out of the solution if we raise the temperature to 80 degrees? We know that NH3 is a gas. Remember the decreasing line? So if you increase the temperature, gas is going to exit the solution because you're exciting those particles. All right. Now, we want to know, well, how much? We can actually look at the solubility curve and it will tell us how much will bubble out of solution. So at 80 degrees, let's follow that same line, we're right here. That's about halfway in between 10 and 20, so let's call it 15. So the saturation point or the solubility limit at 10 degrees is 70 grams, and then at 80 degrees it's 15, so all we got to do is subtract the two. And that will tell us how much bubbled out of solution. This is going to be 65 grams. Now, on your study guide, if you guys saw the solution key, I had 78 minus 15. That's just a typo on my end. This is the right answer. Oh, I made another goof. I meant 55. I apologize. So on the study guide, it says 63 is the answer. The answer is 55 grams. That is your answer. And I will make note of that on the announcements tab. I'll write a little star next to it and tell you that that's a typo. Okay, sorry about that. So that's number 3. Number 4, a student is trying to dissolve all 50 grams of NH3 in 50 grams of H2O at 0 degrees Celsius. Will the student succeed? So can we dissolve 50 grams of NH3 in 50 grams of H2O at 0 degrees Celsius? All right, so we aren't looking at 100. We are looking at 50. So that's going to be half, whatever it is, half that, right? So we got to look at NH3, and we got to look at 0 degrees Celsius. So here's NH3 again. At 0 degrees, we can dissolve about 90. Now, that's in 100 grams of water. What if we had 50 grams of water? Well, if we had half the water, we can dissolve half the solute. So half of 90 is 45. So the maximum amount we can dissolve at 0 degrees Celsius in 50 grams of water is 45 grams. So we're trying to dissolve 50. Can we? No, we cannot. Okay. All right, number 5. I'll do this in a different color. Let's do purple. A saturated solution of KNO3, that's potassium nitrate, and 400 grams of water at 50 degrees Celsius is cooled to 10 degrees Celsius. How much KNO3 will come out of the solution as crystals? Now, this is the same idea as number 3, except we're dealing with a solid now. Okay, so we have a saturated solution in 400 grams of water at 50 degrees Celsius. So let's start right there. Got to figure out the saturation point, so where it lands on the line. Now, we're not in 100 grams of water. We're going to be in 400 grams of water. So wherever we land up on the line, we have to multiply that by 4. Okay, so it says at 50 degrees Celsius, and it's KNO3. So 50 degrees Celsius, KNO3 is right here. Okay, now that's going to be 85. It would be 85 grams in 100 grams of water, but we're dealing with 400 grams of water. That's 4 times the amount of solvent. That means we can dissolve 4 times the amount of solute. Okay, so you have to do it. Go ahead and do 85 times 4. Okay, and I have my calculator if you guys want to do it with me. 85 times 4. You get 340. 340 grams. So you can dissolve 340 grams at 50 degrees Celsius with 400 grams of water. Okay, nice. Now let's move on. Now it's asks you how much will come out of solution if you cooled it to 10 degrees. Okay, so at 10 degrees now, at 10 degrees, let's move down the line. Let's call it, I don't know. Whoops, I don't want that. At 10 degrees, right here. That's a little above it. Let's call it 21. How about that? 21 right there. Now, we can dissolve 21 grams in 100 grams of water, but in 400 grams of water, this would be 21 times 4. Okay, 21 times 4. If you can't do it in your head, do it on a calculator. It's going to be 84, but if you want to double check like me, 21 times 4, boom, is going to be 84. Okay. All right, so I'm going to go ahead and finish this up down here, and then I'll erase it. So we got to do 340 grams minus 84 grams. And once again, just to double check my work, I'll do it on my calculator. 340 minus 84. And then we get 256, and that is correct. 256 grams. Okay. All right, now on the study guide, number 5, it looks like I put 64, but the real answer is 256 grams. I'll have to look at why that's the typo, but focus on these answers, okay? All right, number 6. Let's go ahead and do this last one. I'll do it in a different color. Let's do blue. Explain why solids become more soluble as temperature increases and why gases become less soluble. And we talked about this. Okay, as we increase the temperature of solids in a liquid, so if we increase the temperature, that's going to break up the electrostatic force. It's also going to allow the water molecules to move and bounce around and collide more frequently with those solute particles and break it up. And so that's why it's able to dissolve more frequently, or it's able to dissolve more and more easily at those higher temperatures. And gases is the opposite, right? So when we increase the temperature in gases and liquids, the gases are going to become excited and they're going to be able to exit the solution. Okay, now once again, let's go over the typos on the solution key on the study guide, and I will fix those for you. This one right here should be 55. That is correct. And this one right here was 256. So 55 and 256, those are the correct answers. And like I said, I will fix those on the announcements tab. So just make sure that you make note of it. All right? Okay, hope this helped.